Next we are going to talk about 634. 634, let's see. Okay, so the IW layer is deposited on a substrate using a sputtering tool. We have the data set down here in table 6E14. This table contains layer thickness measurements in angstroms on 20 subgroups of 4 substrates. So let's get the data set carefully. So we have 20 subgroups or 20 samples, and in each we have 4 observations. Set up XBAR-R control chart on this process. The process is in control. Revise the control limits as necessary, it says. So we are going to go to stat graph, control charts. Oh, first let's get the data set, how it's given. Sorry about that. So let's enlarge this and see how it looks. The data set 34. It is given in one column, right? So these are the sample numbers, these are the data elements. So it is given in one column, so that's good to know because we need that. So go to control charts, variable subgroups, XBAR-R. Okay, so all observations for a chart are in one column. We are going to go to 34. 34, these are the sample numbers, these are the subgroup numbers, these are the data sets. So we are going to select this. And subgroup sizes are 4. We change that. Let's check XBAR options. We are going to erase all these. These are for the previous data question. We are going to erase that too. So anything else? Nothing else. So click OK. Click OK. Okay, so we get this nice XBAR-R charts here. As you see, there's a problem with this point, which is sample number 18. Sample mean is also given. So in our chart, no problems. So so we need to revise the control limits, because it says revise if necessary. Okay, so we are going to exclude sample or subgroup 18 from the control limits calculations, and then we are going to calculate the control limits again afterwards. So okay, so let's see, let's give it a name. Okay, charts or XBAR-R charts with using 20 samples, okay, or subgroups. It's the same, but they use subgroups, so let's use subgroups. Click OK. Alright, I'm going to close that, and then so I'm going to exclude that number 18. Okay, so am I going to do that? So I'm going to go to everything is the same here, but I'm going to go to XBAR-R chart, and okay, we could use like omit the following subgroups. So I'm going to omit only 18 here. Okay. And I want to actually keep the same mean. Okay, for that I need to go, let me send this. Okay. Okay, so I have the same R bar changed because we excluded 18. Also X bar is changed just a little bit, I think. Yeah, very little, since we excluded. Okay, control limits is not going to change a lot. So so this is the point. Let's make it bigger. This is the sample 18 that we excluded, and we recalculated the upper control limit and lower control limit excluding that point. So these control limits, they changed. Okay, subgroups omitted from the calculations is just number 18. It shows it here. Okay, so we are going to write the name. Control limits recalculated after omitting a sample 18 or subgroup 18. Okay, click OK. So as you see, no additional is in the graph. Let's recall that graph. Okay, no additional subgroups are beyond the control limits, so these limits can be used for future production. So we are going to say, okay, let's send it first. Okay, I'm going to make it smaller. Okay, let's send it to, okay, send toward, okay, and afterwards we are gonna say no additional subgroups are beyond the control limits. Okay, so we use these control limits for future production. Okay. Okay. Next, so let's save it. So we have this. Okay, I want you to look at the results as well. For our chart, there's no bad points, so nothing in here. But for test results for XBAR, this failed point is 18. You can see it here. Okay. Next, what's the question next? Okay, estimate the mean and standard deviation of the process So we are going to calculate that, but excluding the subgroup 18. X bar is this, the new one, right? Sigma standard deviation is R bar over D2. For D2 we have to go to the table and choose where the sample size is 4, and it is 2.059, and R bar is 1674. You can see it in the graph as well, 1674. Yeah, this is the after omitting sample 18, so we take R bar after omitting sample 18. Okay, and this is 6 bar. Is the layer thickness normal distributed? This is the normality test. Excuse me. We got basic statistics and normality test. The variable is 34. Okay, let's click on that. So the data set lies on this line, so it passes the normality test. We say it. Okay, so we are going to send it to our output as well. Okay, anything else? Let's see. 634. Okay, if the specifications are at 450 plus minus 30, estimate the process capability. Upper specification level is plus 30, lower specification level is minus 30. Actually 450 plus 30 minus 30. Okay, so CP is the difference between these two over 6 times 813. So this is 123, which means the process is capable. So the capability test, we go in there, we go to quality tools, capability analysis, normal, after we check the normality, 34, select single column, subgroup size is 4. Okay, let's say, yeah, lower specification, we have to enter that. Okay, lower specification was what? Let's see it. Okay, 450, 480. I mean, lower one, 420. 420, upper specification level 480. Okay, 480. So we click on that. CP is, let's see, yeah, lower specification is 420, upper specification is 480. Okay, sample size is 80, that's fine. Okay, I'm just checking. So we can see the normality here. ppm less than lower specification level is 19.66. ppm greater than upper specification level 294.16. Okay. We can send it a report to the Word file as well. Okay, let's see what the Word file says. Okay, CP, let's make it smaller. CP is what, 1.18, hence it is bigger than 1. Okay, so the process is capable. The process is capable. You can compare this with the manual result. The manual result. In the manual result, it would be close to, yeah, the manual result is close to this value actually. Okay. Okay, that's the end of it.